The numbers that are the easiest to work with are the single digit numbers. So this is where I'm focusing now when I'm teaching divisibility, because those are the ones that you'll be able to do mental math with the fastest. We've got a lot of our chart already talked about. 2s, 4s, 6s, 8s, 5s, and 10s, and 11s are already quite easy to work with. So I'm using these in these order. My thinking order is going to allow me to think of these numbers in this way before I add on to some of the ones that have a little bit more work to them. When you are dividing by 3, or when you're trying to decide whether the number in question is divisible by 3, the very first thing that you're going to do is add the digits of the number that you're considering. So if you add the digits, and then the second step of that would be to divide by 3 after you add the digits. If the total is divisible by 3, then the number in question is divisible by 3. The exact same rule applies to 9s. After you add the digits of the number that you're trying to figure out if it's divisible, if the total of those digits is a number that is divisible by 9, then the whole entire number is divisible by 9. So there's 2 steps in thinking on this one. You're going to first add the digits, and then you divide by 9. As long as you're adding the digits, you might as well check these 2 off at once. Let's say we were working with the number 816. To use this 3 9s rule, you would have to add the digits of 816. 8 plus 1 is 9, and 9 plus 6 is equal to 15. Well, 3 will evenly divide into 15 because 3 times 5 is 15. So 3 is going to be able to divide into 816 without a remainder. But 9 does not divide evenly into 15. So if we were to divide 816 by 9, we would get a remainder. So our fraction, let's say we have the number maybe 30. Well, let's make it 30. Let's make it 39 over 816. We already added the digits here and got 15, so we're good. 3 plus 9 gives you 12, and 3 is also divides into 12. So I know that I can divide this fraction by 3. 3 divides into 3 one time. 3 divides into 9 3 times. So we've just reduced that to 13. 3 divides into 8 twice with 2 left over. 3 divides into 21 7 times. 3 divides into 6 twice. So our answer to this problem is 13,272 over 272. This one is probably in the lowest terms. We do not have even numbers on both top and bottom, so we can't go on with this fraction. If we were to add the digits now, 1 plus 3 is 4. 3 is not going to divide evenly into 4, and 9 is even higher. So we cannot further divide this by 3. It might be divided by some other number, possibly the 13, but we haven't studied that far yet. So that's what I mean when I say add the digits and check to see if the total is divisible by 3 or 9. So now we have a way To test our numbers, if we have 2s, 4, 6, and 8, same rule. That's why I left it at the same color. The 3s and the 9s are similar, so I grouped those together. We know that when we have numbers that end in a 0 or a 5, that we should be thinking about our 5 and our 10 to divide. And our last number, 7, is one that in all the time I've been teaching, I have never found a good trick for 7 that didn't take a long time to do anyway. So I saved this one for last. And I always divide by 7, and that would be a finger division, dividing by 7. But this is a screwball-y one, so I'm saving that for last. So these are the rules for divisibility. So these are the helpful ones. You may want to write these down and keep them next to you the next time you have to reduce fractions or tell whether a number is divisible by another. Pretty soon you're going to get used to this chart and it will become part of you. But now I want to take some time to actually do some problems with the last rules that I've taught you.